Hello dear student, welcome back in the practical of pharmaceutical chemistry 2. In this part we are going to deal with the experiment number 2. That is, the aim for experiment number 2 is to determine the melting point of the given solid organic compound. So one thing should be remember that the melting point is a physical constant which is associated with the solid organic compound, whereas the boiling point is associated with the liquid organic compound. So in this experiment we are dealing with the melting point of given solid organic compound. So as far as the melting point is concerned, the definition of the melting point is that the temperature at which solids start to melt and convert to the liquid state, that temperature is called as melting point. Simply, the temperature at which solid convert into liquid, or solid start to melt and then it converts into liquid state, that we are calling a melting point. That temperature we are calling a melting point. Okay, so as this is a say molecular arrangement of these substances, like this is a solid in which the molecules are compactly arranged. All the molecules are compactly arranged, as well as the molecules are tightly bonded with each other. Two molecules are tightly bonded with each other. This is the liquid state in which the molecules are randomly arranged, or we can say that they are loosely arranged. As compared to solid, in a liquid they are loosely arranged because there is a intermolecular bonding got break and they are now free to move. In this solid case, they cannot be moved within the state itself, whereas in the liquid they can move. Liquid molecules can move because the intermolecular bonding get broken down and they are free to move within the liquid state itself. And this is the molecular arrangement, or the arrangement of the molecules in the gaseous state, where which the molecules are completely free, and they can escape the system also, and they are much loosely arranged. There is quite a distance between the intermolecule, or between the two molecules. There is a quite difference, and they are very loosely arranged, and they are free to escape, while in case of liquid they are not much free to escape. And in case of solid, they cannot move within themselves. Okay, so this is a three state we have discussed: solid, liquid and the gas state. Now as per the conversion of the solid to liquid, we are calling a melting. Okay, conversion of solid to liquid, the process called as melting. For that we need a temperature. If you are providing the heat, then the molecule will absorb the heat, the intermolecular bonding will get break down, and they are becoming liquid. They are melting, solid are melting to form liquid state. Next, reverse of this, when we are going to convert liquid to solid state, this process called as freezing. Okay, we have to do the freezing to this liquid so that it will convert to a solid state. Okay, now next step, wherever there is a heating further, if you are going to provide the heat energy to the further liquid state, that is converted to a gaseous state. Okay, means the molecule will absorb the heat energy, and they are again more free, they are having more energized, so that they can evaporate. The process called as evaporation or evaporating, that is from liquid to gaseous state. Whereas if you want to convert the gaseous state to the liquid one, the process called as condensation. Okay, for example, we will take the example of the water, that if the solid, if you are talking water, solid state will be the ice. Okay, ice subjected for melting to become a water will be in a liquid state. Whereas the liquid or water, if you are going to heating, provide the heat, it will absorb the further energy and get evaporate to the steam. So steam is the gaseous state of the water. So all three states we had discussed about the water. That is, in case of solid, it will be in the ice form, whereas in case of liquid, it will be in the water form, whereas in case of gaseous state, it will be in the steam form. Okay, and reverse of that, if you want to condense the steam, the process is condensation, it can convert into a water. If you want to convert this water to the ice, then we have to go for freezing. Okay, melting we are calling boiling or evaporation actually. Okay, and the temperature required for conversion of solid to liquid, that we calling melting point, and the temperature at which the liquid convert into gaseous state or the vapors, that we are calling boiling point. So both these are the temperature or the transition state or borderlines. Okay, below the melting point, the substance will be in the solid state. Above its melting point, the substance will be exist in the liquid state. Same substance. Okay, for example, below the boiling point, the liquid is available in the liquid state, whereas the substance above the boiling point, the substance will be exist in a gaseous state. Okay, so this is a borderline temperature which changes the state of the substance. And again, third stage, we should know that directly solid again can be converted into a gas state. The process is called as sublimation. Okay, like for example, we know the camphor, camphor is a solid, but directly it will convert into a vapor, essence, directly evaporate and convert into a gas state. It will not necessarily, it will not melt or not convert into a liquid state. It will directly convert into a gas state from solid. So the process is called as sublimation. So all these processes we had discussed: melting, evaporation, freezing, condensation and sublimation. Okay, so this is all about, and the temperature at which the solid convert into a melts and convert into a liquid state, the temperature is called as melting point, and that is the topic, melting point. Okay, melting point of substance. Next, now new concept, as far as the new concept is concerned, we are going to determine the melting point for purity. Melting point indicate the purity. Melting point is one of the physical constant, and if there is a sharp melting point, it shows the high purity of the substance, or substance is highly pure. If there is a no sharp melting point, there is a say not exact melting point, there is a say variation in the melting point, or melting point range is there, it means that it is not a pure substance. It will have some other type of impurities that we are calling the judging of the purity of a substance on the basis of the determination of melting point. If you are detecting, if the melting point is sharp, then the substance we can say that it is a highly pure substance. Next, again the melting point is for the identity, because the melting point is one of the physical constant, and that will be fixed given by the official pharmacopoeia for the particular substance. For example, benzoic acid is there, it have 122 degrees Celsius as a melting point. So one can judge the one of the identification parameter as a melting point in order to identify the compound, whether the compound is benzoic acid or not, or given sample is benzoic acid or not. That is by determining the melting point. So one will determine the melting point, and if the melting point is matches with the official range given into the official pharmacopoeia for that particular substance, like I had given the example of benzoic acid, it shows the 122 degrees Celsius. If it is near to 122, the substance will be a benzoic acid. If it is not, or it is far away from these melting point range specified by the pharmacopoeia, then we cannot say that the substance complies with the official pharmacopoeia. It will have the impurities, the substance will be misbranded, okay, or mislabeled, might be adulterated. Okay, so this is the second proposition or second concept, that the melting point of substance can be again used for the identity of the substance, to identify the substance. Next, this is a procedure as well as the melting point assembly. So in this case you can see that the melting point assembly consists of the Thiel's tube, which has the thermometer placed within that, and we are placing a liquid paraffin filling to this above this side arm. Side arm is just for the heating, uniform heating, and this is the arrangement of the thermal capillary filled with the substance, fine capillary filled with the substance attached to the thermometer, and then it is to be immersed into the liquid paraffin placed into the Thiel's tube. Okay, and then we have to start heating, and this is the arrow indicating that the liquid molecules get heated from here itself and will pass to the upper side, and the cold molecule will come down and will enter into this side, so that there is a turbulence flow of the heating, and there will be a uniform heating. Okay, uniform heating, and that's why the speciality of the Thiel's tube is that it have a side arm just for the uniform heating. If you are heating by bottom of this tube, the uniform heating will not be there. If you are heating by side arm, then there will be a turbulent flow of the heat, and the uniform heating will be there, and uniform heating is required for gradual increase in the temperature. There should not be a sudden increase in the temperature. If you are heating at the bottom, then there may be a chances of sudden increase in the temperature, but if you are heating by side arm, then there will be a gradual or slowly increase in the temperature, and that is helpful for detection of the melting point. Okay, so this is the assembly. I have given the video how to fill the substance into the small fine glass capillary, and how to attach the substance to how to attach this filled capillary to the thermometer. Already animation is given, you can see that. Just I am going to explain here the assembly. Okay, so first we have to arrange the clamp stand attached with the Thiel's tube filled with the liquid paraffin. Alternate liquid can again be used, that is concentrated H2SO4. If the liquid paraffin is absent or not available, then we have alternate liquid, that is concentrated H2SO4. The reason why we are using the liquid paraffin is that because the liquid paraffin is having high boiling point, like it have around about 250 degrees Celsius boiling point. So till that the liquid becomes stable. Liquid paraffin will be stable, will not showing any bubble or will not showing any interference, and most of the organic compounds will have melting point range below 250 degrees Celsius. So this can be helpful for using this liquid paraffin, stable liquid, in order to fill into the Thills tube, which is a stable one. And the arrangement is like this. This is a fine glass capillary attached with the thermometer. The attachment or the tying of this fine capillary tube filled with the substance of which we have to determine the melting point, that should be parallel to the bulb of the thermometer, like that. Okay, we have to tie either with the rubber band or with the thread. First we have to fill the glass fine capillary with the substance. We have to seal with one end of this glass capillary, and with the open end we have to fill the substance. How to be filled you can see in the animation, and that to be tied in parallel to that of or the substance and the bulb of thermometer should be parallel, so that in that way it should be tied with the rubber band or with the thread. Okay, and that this will be immersed into the liquid paraffin filled with the filled into the Thills tube. Okay, and next we have to see that the immersion of these bulb of thermometer again to be mid of these side arm. Like for example, this is the upper end of the side arm and this is the lower end of the side arm. The midpoint is this. So this is the proper way, and the middle point is important one, as well as this position is important one, so that the uniform heating to be get to the substance to get melt. And then after heating we have to observe continuously the temperature by thermometer and the substance whether it got melt or not, and we have to note the temperature at which the substance get melt and convert into liquid one. That can be visualized, and that is our observation. How to determine the melting point? What we have to do, you have to heat it slowly by the side arm, so that there is a gradual increase in the temperature, and we have to note down, we have to observe both the temperature on the thermometer and the substance into the fine glass capillary. Okay, both the things to be observed into the while heating, and we have to note down that temperature at which this solid get melt and convert into liquid one. That temperature is called as melting point of substance. For accuracy we have to take twice, we have to repeat it, or maybe 3 times we can take a reading, and average of that the temperature or the melting point we can take for more accuracy. Okay, so this is the arrangement. You can see that the substance filled into the capillary, fine glass capillary, and the bulb of thermometer is a parallel one, and that to be mid of this side arm. So this is the say assembly arrangement and the procedure to determine the melting point of substance, and remaining regarding the theory behind the melting point determination, as well as the procedure how exactly to be perform the melting point, how to arrange the assembly, and what precaution to be taken. So this again the most important precaution, as far as the precaution is concerned, we have to never wash these Thills tube after use or before use. If you want to take for experiment, then you never have to be wash these Thills tube. Okay, you just drain this, what is the liquid paraffin we had filled into the Thills tube, we have to drain it and just keep it as it is. Okay, we don't have to wash this Thills tube at any cost, any condition. Okay, and next time if you want to use it, take it as it is and fill it into the fill the liquid paraffin and use as it is. So that's why I'm saying that there should not be wash these Thills tube before the experiment or after the experiment. Normally you have a habit to wash the glasswares, but this glassware should not be washed, never to be washed, so that if what happen if you are going to wash these Thills tube, so there is a say moisture content will remain into the Thills tube, and that will come in that will come during the experiment with the heated liquid paraffin, and that causes the bursting of the tube. The tube will get burst out, and all the heated liquid paraffin, heated oil, we can say the heated oil will be exposed to the experiment, those who are going to be performed, and that is hazardous one. Okay, heated oil is being exposed due to the bursting of this Thills tube. If you want to wash this Thills tube, so never wash this Thills tube before experiment, as well as never wash after the experiment. Keep it as it is, drain it and keep it as it is. Okay, so thank you for watching, and thanks for being with us. All the demonstration is given in the video in a Moodle. Thanks for concern. Thank you.